Outcome number 8. I can define a molecular compound, give them name, and write formulas with them. So here we're going to practice two things. We're going to practice naming molecular compounds, and then we're going to practice writing the formula down for molecular compounds. And we're just going to focus on a few things that you need to know. So let's start with example number 1 here, PCl5. First thing you need to figure out is what the P stands for and what the Cl stands for. Actually, the first thing you need to figure out is if it's a molecular compound. And you know if it's a molecular compound if you have two nonmetals together. In this case, we do. We do have two nonmetals together. We have P, which is phosphorus, and then we have Cl, which is chlorine. Very simple. Like you would do in a ionic compound, you take the first element and you write it down in its entirety, in its entire name. So phosphorus. Then what you do is you take your second one and you write chlorine. And then you finish, you change the ending from "ine" to "ide", the same as you would in an ionic compound. Chloride. One thing you need to add, it's not done quite yet. You need to indicate this 5. You need to show how many molecules there are in a, or how many atoms there are in a molecular compound. Phosphorus, there's only one. It's invisible, so you don't need to write anything down. In the second one, no, chloride, there's 5 atoms. So what you need to do is you need to add a prefix. So phosphorus and the prefix for 5 would be penta. So you write pentachloride. So phosphorus pentachloride. And there you go, simple as that. If we look at the next one, we have B2H6. And you'll notice that both of these are gases because molecular compounds are often found in gas form or liquid form. Ionic compounds are found in solid form. So B2H6, is it a molecular compound? Well, let's see. B, oh, boron. Boron is on the right side of the ladder, and so it's a nonmetal. H. H is kind of one of those tricky ones. It's actually found on the other side, right here, hydrogen. But hydrogen has got a special, it's a special element. It could be either a metal or a nonmetal. In this case, it's acting as a nonmetal. So it's going to have a negative atom, charge, and so it's sharing its electrons instead of giving its electrons away. So we have boron, we have hydrogen. Very simple. We start by writing the first name, boron, in its entirety. And then the second one, hydrogen. Hydrogen is one of those special ones. You won't say hydrogenide because that doesn't sound good. So you actually change it from hydrogen to hydroxide. And you finish with "ide" again, hydroxide. So boron, hydroxide. Again, it's a molecular compound, so you need to take in consideration the number of atoms for each of your elements. Boron has 2. 2 is represented by either bi or di. So diboron or biboron. I think di makes more sense, so let's add di right here. So diboron, and how many, what would my prefix for hydroxide? 6, which is represented by hexa. So diboron hexahydroxide. Very easy. And that's how you would write down the chemical name. So you just need the prefixes for that represent your number of atoms. If we look at the second part, it's but we need to write it, take the name and write it into a chemical formula. This is for molecular compounds very, very easy because you just write it according to what it's telling you. So nitrogen, you find that nitrogen is N, so you write AN. It's much easier than a ionic compound. Chloride, so you look at this one, which is chlorine, which is Cl. So you put your Cl, and it says tri. Tri means 3, so I put 3. And NCl3 would be probably a gas. So let's put a G, it's a gas. Bromine. Bromine's actually not a compound. You'll notice that it's an element. If we find it, it's represented by Br. But the reason why I'm putting it here is not because it's a compound, but you need to understand that most elements that are nonmetals are found are diatomic, meaning in nature you won't find them by themselves. You always find them in pairs of two. And they are found, and bromine is a liquid. So I would put a liquid in pure form.